In fact, lambda for first line of bomber series of hydrogen H is more by 1.79 angstrom than the corresponding line for deuterium D. Let us now solve some questions based on Bohr theory. Here is question number 1. The question is, which hydrogen-like species will have same radius as that of Bohr orbit of hydrogen atom? The options are A, n equal to 2, Li2 plus ion, B, n equal to 2 for Be3 plus ion, C, n equal to 2 for He plus ion, D, n equal to 3 for Li2 plus ion. The solution of the question is, the answer is B, because for hydrogen atom we know R is equal to 0.529 angstrom, and for Be3 plus, which contains only one electron like H, radius for second orbit n equal to 2 will be equal to 0.529 into n square by z, that is 0.529 into 4 upon 4. That comes out to be same 0.529 angstrom. Well, question number 2. The energy of an electron in the first Bohr orbit of hydrogen atom is minus 13.6 electron volt. The possible energy value or values of the excited state or states for electron in Bohr orbits of hydrogen is are A, minus 3.4 electron volt, B, minus 4.2 electron volt, C, minus 6.8 electron volt, and D, plus 6.8 electron volt. The solution of the question is, the answer is A, because E is equal to minus 13.6 upon n square electron volt. Therefore, for n equal to 2, E2 is equal to minus 13.6 by 4, and that's equal to minus 3.4 electron volt. Then for n equal to 3, E3 will come out to be equal to minus 13.6 by 9, and that's equal to minus 1.51 electron volt. Therefore, options B, C and D cannot be correct. Question number 3. The wavelength of a spectral line for an electronic transition is inversely related to, the options are A, the number of electrons undergoing the transition, B, the nuclear charge of the atom, C, the difference in the energy of the energy levels involved in the transition, D, the velocity of the electron undergoing the transition. The answer is C, because E2 minus E1 is equal to Hc upon lambda, and therefore lambda is proportional to 1 upon delta E. Question number 4. Bohr model can explain, the options are A, the spectrum of hydrogen atom only, B, spectrum of an atom or ion containing one electron only, C, The spectrum of hydrogen molecule. D. The solar spectrum. The answer is B, because Bohr model is valid for one electron species. Question number 5. Which electronic level would allow the hydrogen atom to absorb a photon but not to emit a photon? The options are A. 3s, B. 2p, C. 2s, D. 1s. The answer is D, because electron present in n equal to 1 can be excited only, so it can absorb photon but cannot emit.